you are making cookies, it is important to always follow a well-written recipe. The same concept can be applied to achieving a derivative, whether by U-substitution or by thinking about antiderivatives. Either method you choose, you will get the same exact derivative. Or in the case of following a recipe about cookies, you are able to substitute ingredients in your recipe to produce the same cookies. For example, here is a recipe for cookies using butter and sugar, where the final product will be a cookie. But you can substitute butter with margarine and sugar with brown sugar and still get the same cookies. For practice problem 1, the first step is to raise the exponent, since we are taking the antiderivative, or integral rather. With this, we then tested the problem by taking the derivative of the equation we created, and the result was the original problem. When using U-substitution to solve this problem, the first step is to determine what U will be. Described in blue, U is x squared plus 1 dx, because it is the part of the problem raised to the highest power. The next step, as outlined in pink, is to find du, the derivative of u, which is 2x dx, and the dx is present because it is the result of the chain rule. The derivative of u then has to be set equal to the remaining information in the problem, which is 8x. Both sides have to be multiplied by 4. Returning to the original problem, it is rewritten and each part is substituted, creating 4 du u to the third. It is at this point that the integral can be taken and the problem is less cluttered. To take the integral, the exponent is raised to the fourth, and the coefficient is then divided by 4, leaving the problem as u to the fourth plus c. The plus c is added at the end because it is a way of showing that we do not need to know how far the graph is sliding up and down. U is resubstituted because without that part of the problem you would not arrive back at the original equation. The first step in practice problem 2 is to avoid using fractions and to bring up the denominator by changing the exponent to be negative. At this point, the integral can be taken. The exponent is raised by adding 1, leaving it as negative 3 shown in the green. The 1/2, as shown in orange with a star next to it, is the undoing of the chain rule. And the step below, where the negative 1/3 is added, is the undoing of the exponent rule. The coefficients are then combined, and the final result is negative 1/6 times x squared minus 4x to the negative third, plus c. The first step in practice problem 2 with U-substitution is to identify what U is. To do so, you look at the problem and see which part is raised to the highest exponent, as well as if any of the parts of the problem is the derivative of another. This then leaves U to be x squared minus 4, as shown in blue. Following this, you must determine what du is by taking the derivative of u, which is shown in pink, and is 2x minus 4. Du must be set equal to the remaining part of the problem, which in this case is x minus 2. To do this, both du and 2x minus 4 are multiplied by 1/2. At this point, you return back to the original problem and substitute the new parts. The numerator is replaced by 1/2 du, and the denominator by u to the fourth. The integral is now ready to be taken, and the problem has been simplified. To avoid the use of fractions, u is brought up and raised to the negative fourth. The next step is to raise the exponent by 1, setting it to negative 3, and then you divide the coefficient by negative 3, which is equivalent to multiplying by negative 1/3. By combining negative 1/3 and 1/2, the coefficient has been found, And the final step is to resubstitute u for what it was originally. For determining your first step in practice problem 3, you should immediately recognize that cosine is the derivative of sine. And once you realize this, the next step is to take the integral of sine squared of 5x and make it sine to the third of 5x plus c. And continue solving using the chain rule and the exponent rule. The first step when using U-substitution in problem 3 is to identify what u is. In this problem, you can examine the equation and see that cosine is the derivative of sine, and that sine is the part of the problem raised to the highest exponent. This then should lead you to a point sine of 5x to be u. Next, you have to solve for du, which comes out to 5 cosine of 5x times dx. And this has to be set equal to the remaining parts of the problem, which is just cosine of 5x. To do this, both sides of the equation are multiplied by 1/5. At this point, you can return to the original problem and substitute the new parts, resulting in the equation 15 u squared times 1/5 du, and then simplify to 3 u squared du, at which point the integral can be taken. To do this, the exponent is raised by 1, and the coefficient is divided by it, leaving the equation to be u to the third plus c. The final step is to substitute u for sine of 5x to the third plus c.